Hello, welcome to Grade 5 Math Blast Week 1. 5 MBT 1, place value relations. Write the value of the 3 in each number. So we have the 3 is right here in the hundredths place, so that the value of that would be 3 hundredths. In this number here, the 3 is located in the tenths place, so the value would be 3 tenths. Compare the value of the 5 in each number. Well, what they've done for us is they've underlined the 5 that they want us to focus on in each number, the digit. So we're looking right here. So we've got the 5. It is in the tenths place. So that is 5 tenths. And in this number, the 5 they want us to focus on is right here in the tens place. So that value is 50. So I want to write this as a sentence. So I have 5 tenths is, I'm going to put a blank here, times 50. So those are the two values, and I need to compare these. Well, 5 tenths is how much of 50, so it's how many times. So I know I can use that principle of place value with 10. So if I divide by 10, the digits all shift, okay? So if I divide by 10, that 50 shifts over, and so the 5 moves from the tens to the ones, so that would be 5. And then if I divide by 10 again, that would make 5 tenths. But I want to write this as a multiplication. So instead of dividing by 10, what I can do is multiply by 1/10. So if I multiply by 1/10, the 5 moved from the tens to the ones, and if I multiply by multiply that by another tenth, or 1/100th, then it would become 5 tenths. So 5 tenths is 1/100th times 50. I could also do this in reverse, so I could compare 50 to the 5 tenths. So now 50 is blank times 5 tenths. So just like multiplying by 1/10, so now I can multiply by 10 to get those digits to move the other way. So 5 tenths multiplied by 10 is 5 ones. Multiplied by another 10 is 5 tenths. So 2 tens, 10 times 10, well, that is 100. So 50 is 100 times larger than 5 tenths. Now, 5 MBT 2I. Whole number exponents for powers of 10. So we have standard, exponential, and repeated factors. And I need to write each of these numbers in the two missing forms. So I have 10,000. I need to write that in exponential form and repeated factors. Well, I'm going to start with repeated factors, so we're multiplying by 10. Now, we just talked about how every time I multiply by 10, the digits move to the left. So 10 times 10 would be 100. Multiplied by another 10 would be 1,000. Multiplied by another 10 would be 10,000. So 10,000 is the same as 10 multiplied by 10, multiplied by 10, multiplied by 10. Now, to write that in exponential form, my base, or the number I'm multiplying by, is 10. The exponent is the number of times I'm multiplying by that base. So 1, 2, 3, 4. So 10 to the 4th. Now we have the line here with 10 to the 3rd. I'm going to do repeated factors first. So base of 10, 3 times. 10 multiplied by 10 multiplied by 10. And now I can write that in standard form. So 10 multiplied by 10 is 100. Multiplied by 10. Shift it one more, that's 1,000. So 1,000. Okay. Now I have repeated factors, so I have a base of 10, and I have 2. Well, now I can go look at that repeated factors, and I can do my standard form. So 10 multiplied by 10 moves one place. It's 100. That's whole number exponents. Now I'll slide this up. 5 NBT3, A, reading and writing decimals. So now I'm kind of doing a similar thing. I've got, in this case, I only have one blank for each line, but we're looking at standard form, unit form, and expanded form. Okay, so I have the number 74 and 42 hundredths. Now here's the unit form they chose. Remember, there's many different uniforms. Now expanded form. So basically for expanded form, what I'm going to do is just write the value, a form of the value for every single place value. So I have 7 tens. So I'm going to do 7 multiplied by 10. So I have 7 of those tens. Plus 4 ones. So 4 multiplied by 1. Plus 4 tenths. Using decimal notation. Plus 2 hundredths. So 2 times hundredths. And I have the rest of those there. So now I have unit form and expanded form. Now we have a small error here on this worksheet, so I'm going to fix that. So that should say 4 times, that was 4 hundredths. So I'll fix that there. Now I need to convert this into a standard form. So I have 3 in the hundreds place. So we'll kind of do that to make that easy. So 3 hundredths, 7 tens, 9 ones, and 4 hundredths. So I have go to the hundredths place, and I'm going to have to put a 4 here. Now notice I have 0 tenths, so I'll put a 0 there to kind of hold that place. 283 and 4 hundredths. Now they have the expanded form here. Now I need to write this number using only ones and hundredths. Well, if I look, yes, there is a 3 in the ones place, but 3 ones is not going to build this number right here. I would need 283 ones. So 283 ones. And then I have 4 hundredths. So I can build this number using 283 ones. So if I laid out 283 ones, and then 4 hundredths, it's equivalent to 283 and 4 hundredths there. Okay, and then that section's all done. Now we're comparing, so use the correct relational symbol to make each sentence true. And this is 5NBT 3B, comparing decimal numbers. So we're going to be using the less than, greater than, or equal symbol. So let's look. Now when both of these are in standard form, when we're comparing standard form, we start with the largest place value. So in both of these numbers, we have hundreds. So 3 hundredths and 3 hundredths, those are equal. 4 tens and 4 tens are equal. 6 ones and 6 ones equal. 6 tenths and 3 tenths. Well, 6 tenths is greater than 3 tenths, so we know this number has to be larger. I do not need to go to the hundredths place when I'm looking largest place value to the smallest place value present. Once I find one that's different, I can stop right there. Now here, I have unit form. I have 537 tenths, and I have 932 hundredths. So one of the things here is I could compare the unit forms if they're in the same units, but these are tenths and hundredths, so this is going to be kind of difficult. But what I can do is I can turn these both into standard form and then compare them using the same strategy that I did here. So 537 tenths. So to make this a little simpler, I'm going to put my place value, my decimal point there, and I'm going to place my place values in here. Okay. Now the reason I went here is because these are tenths, so I only need to go as far as my tenths. So 537 tenths. So that's right there. So I could build this number out of 537 tenths. Now over here I have hundredths, so I'm going to put my decimal point there, so I kind of have an idea where everything is. Now I need hundredths, and now I have 3 digits, so I'm going to put 3 places there. 932 hundredths, so 932 hundredths is what I'm looking at. Make my 3 a little easier for you to read. Now I can easily compare these. So I look here, I have 5 tens. Well, if I extend my place values there, I have 0 tens. Well, 5 tens is obviously larger than 0 tens. So greater than. Now I'm looking at an expanded form. And again, so I can compare these expanded forms. I have hundreds, hundreds, tens, no tens. So that means this number here is larger. I could also convert these to standard form just so I'm absolutely sure. So I have hundreds, tens, and they need to go to the tenths. So I'll put my decimal. Here's tenths, ones, tens, hundreds. So that tells me I have enough places. So 9 hundreds, 3 tens, 0 ones, because there's no value there, 8 tenths. So I have that number built. And now hundreds, ones, and tenths. So I'll put my decimal point. Tenths, ones, tens, hundreds. 9 hundreds, 0 tens. Notice there's nothing there. 3 ones, and 5 tenths. And so now I know. I'll put that there. And now I can compare them just like I compared them in that expanded form. 9 hundreds is the same. 3 tens, 0 tens. So this number is definitely greater. Now, round 47,651 and 75 hundredths to the nearest. Now we're going to round them to the nearest 1,001. Now I'm going to use a vertical number line. I need 2 of them, 1 for each problem. Now this first one I'm doing thousands. So what I look is how many thousands are in this number here. Well, if you look, there are 47 thousands. So 47,000. Now, what would one more thousand be? That would be 48,000. You should recognize this vertical number line from 3rd and 4th grade. Now, the midpoint between 47,000 and 48,000 is 47,500. That's my comma there. And now I just look at this number, 47,651 and 75 hundredths. Well, there's 6 hundredths here. There's 5 hundredths there, so I know that number is going to be right about there. That's where it's going to be located. And so I just have to determine, once I hit this midpoint, it's closer to 48,000. Up to that midpoint, it's closer to 47. Well, it's a little past the midpoint, so 48,000. Okay. Now, 1. Well, I ask myself, how many ones are in this number? Well, there are 47,651 ones. Now, what would one more one be? 47,652 ones. Halfway or midpoint would be 47,651 and 5 tenths, because then 5 more tenths take me to 2 ones. Now I look at this number here. I have 47. I can kind of use my midpoint as my reference here. 47,651, and here I have 7 tenths, and here I have 5 tenths. So I'm going to be just past that. We just said, once I hit that midpoint, I go up to the next one. So 47,652. This was Grade 5, Week 1 Math Blast. Thank you.